And today I wanted to share with you our Sumo Logic application observability platform, how we do it, why we believe it's important, and then go through a quick and effective troubleshooting scenario. Just one of the use cases that you can use to really leverage the power of the Sumo Logic platform. And then we'll finish off with our global intelligence service, focusing on Kubernetes and how we help our customers not only be able to quickly troubleshoot applications, but also optimize them. So they're able to continuously improve as their application grows, complexity increases, and Sumo Logic is there for our customers to continue that improvement process. So let's talk a little bit about observability. So for us, observability requires rich data, but it also requires richer analytics to get from alert to resolution. As we can see in this iceberg slide, as you go deeper into the application, you're increasing the number of telemetry that you have to look at to be able to troubleshoot your application. So your metrics get you quick MTTI with unified alerts, and then you want to go and diagnose, and that's where our logs and traces are coming in to give you contextual information for better time to diagnosis. But when it comes to actually figuring out why that problem happened, the richest set of data is going to be in your logs. So with Sumo Logic, we get all this telemetry, we analyze it, we correlate it, and we're able to give you that end-to-end view. And we know that telemetry is exploding as you adopt more services, your application grows in complexity, and you need a platform that really allows you to scale as your machine data and telemetry is scaling with you. So with Sumo Logic, all of this information comes into one single platform. And as I mentioned, we do an analysis as it's coming in to provide metadata and contextualize what infrastructure is associated with what telemetry, so you can get this end-to-end view. Because at the end of the day, our goal with Sumo Logic Observability is to provide user-friendly UX and common query language, so you can query across all of your telemetry, and then integrations and out-of-the-box dashboards, which are very important because your application is changing rapidly, and you want to spend more time managing your application rather than managing your tools. So these out-of-the-box dashboards and alerts reduce that setup time. And then most importantly, the microservices auto-discovery allows you to discover new information, new infrastructure, new containers as those become visible and available in your application. So we can go through all of these, but I wanted just to finish off with this benchmarking and optimization. Because Sumo Logic is a multi-tenant platform, we're able to leverage analytics across all of our telemetry to then be able to give you golden single benchmarks. So you can see how your application is performing compared to benchmarks across the spectrum. And if you want additional information, dive a little bit deeper into some of these things, I really invite you to set up a customized demo with some of our SCs and team members, so you can really dive deep into your specific scenario, how you want to leverage observability, and what are the real issues that you're trying to figure out. With that being said, let's go into this live demo. So for this scenario, let's pretend that we have this application behind load balancer. We have a payment service that then is connected to an account service. This is all being hosted in AWS. It's running on Kubernetes and Java, and everything's fantastic and really going well. However, at 3 a.m., you get this error message, and you quickly go in and say, okay, my SLO has been breached. There's a playbook associated in this alert. So we go and click it. That takes us directly into our Sumo Logic portal. So let's jump in there. So as we look at our payment service SLO, we can see our error rates and outliers have increased. And of course, that's not something that we want to see ever. But now we have to go and start triaging and troubleshooting and make sure that we can recover fast enough. Additionally, we have configured this to also give us the names and accounts of all of these customers that have been impacted by these errors. And this is amazing information for your customer success teams to be able to then go proactively reach out to these accounts and do some of that relationship building by acknowledging something's wrong, how can we help you, and being proactive while the information is, while the issue is being worked on. Additionally, we have configured this to also show us some business metrics. And really that helps you understand what is the impact of this specific issue on your business. How is it affecting your transaction volume, for example, in here, or your dollars transferred? And then we can see all of the infrastructure associated with this specific error. And this is really important because if it's just a single pod that's having the error, you could go in and then look at the infrastructure associated with that pod. Again, as I mentioned, all of this data is correlated. So we know that which container is running on what pod and deployment and all of this really useful information. However, we see that this problem is happening across multiple different pods, which might indicate that something else is happening. So let's look at it from an application-centric point of view. And we do that by opening up the service map. And the service map allows us to look at the service interdependencies from the payment service, calling the account service, calling other specific issues. And here we are gonna check out the outlier deviations to see where things are going awry. And we see that the payment service, which was our initial error, is connecting to the account service that is having a lot of errors and a lot of anomalies. So that tells us that the problem could be now associated with a service call into the accounts. We can then click on the accounts so that we can see what's going on. And to do the troubleshooting, I'm going to go and open up all of the traces that are associated with this, that have a span associated with the account service. And then I'm going to filter this a little bit further with anything that has a lot of errors. So now we see all of these different transaction traces from the root of the payment service that experienced errors. We can go then click any one of these to then start looking at what that problem happened. And you can see here that payment service then sent information to the account service. And if I hide the services, you will see a red bar. And this red bar indicates that there was an error happening. So if we go down to where the error first started happening, we can then open this up and see this CRUD repository by ID came back with an error. We can look at all of the metadata associated with this specific span that allows us to look at what the Kubernetes side of things, all of this information, as well as the infrastructure associated with it. Given that there's an error, let's go and look at the specific container that was serving this. And now now that we found out where the problem is happening, we now are going to be able to look at, well, why did it happen and how can I fix it quickly? And the best way to do that is to dive into the logs for that specific container. And we go in, we see that there's like 25 different messages, and this is all a lot of information that you have to sort through. And with observability and with modern applications, we know that telemetry is just exploding. You're having more microservices, more containers, more pods, more Lambda functions. All of these different things are creating a lot more information that is almost impossible for a human to be able to then go and look and really understand to find out the problem quickly. With Sumo Logic, we have a log reduce function that goes in and gives you the signatures based on really active and on-demand analysis of all of these log signals. And by doing that, we can go from 25 different pages to a set of 14 different signatures. And here we can see that there was 326 different signatures that had an error of too many connections as they were connecting to that database. So now we know we have that smoking gun. We can go look at the database, increase the threshold so that we can recover from this as quickly as possible and then restore service. So this is one scenario that allows us to go from a metric signal of error rates to then troubleshoot and diagnose across the different services and interdependencies. And what you saw here is a simplistic example, because your application might have like tens, hundreds of different services that are all interconnected. And it's really important to be able to visualize this in a service map and then be able to extract that one thing that is really erroring out, and then look at all of the logs associated with it, but through a lens that allows you to really analyze and visualize all of these things. So now that we've done a troubleshooting scenario, let's look at how Sumo Logic can help you now optimize these different applications so that you're being more proactive in how you are managing your risk as well as managing your costs in the context of your Kubernetes application. So moving forward, we solve this, we can close this out, and it's 3 a.m. I can go back to bed, and then in the morning, I can go and start doing a more analysis on how am I going to really help the application be more optimized and improve upon it. So with this, Sumo Logic has the Global Intelligence service. And this, we're going to focus on global intelligence for Kubernetes. However, this is available for all different applications, such as Nginx, Apache, and it allows you to really benchmark your deployment. And taking advantage of this multi-tenant application, let's look at this business problem around Kubernetes. So as you're provisioning containers, you have your requests and you have your limits, and you may be sort of guessing where these have to be, and you could be over provisioning them where you're wasting compute on each one of these deployments, or you could be under provisioning them where you're risking errors and out of memory termination, etc. With your deployment. And what we found is that around 80% of the containers that we've profiled are unoptimized for CPU, and 86 are really unoptimized for memory. And looking at our container counts, 75th percentile, looking at 220 different containers that need these 4 parameters set per container: CPU, memory, requests, limits. And it's really tedious, and it's hard to manually set all of these up. And then as your application changes and the demand changes, like what does that actually do? So Sumo Logic has added capabilities so that you can now look at how you can do reliability optimize. If this is a really mission critical application that you cannot have any errors, or you can cost optimize, or you can balance around your risk and cost around each one of these containers. And the way that we do this is by doing a trailing analysis of 8 days of the time series of requests and errors across around 17 million containers that we've profiled since mid-November of 2020. And we keep this information so that we can apply it to your specific deployment. So we're trailing your deployment and then applying this large data set and observations to then be able to give you recommendations around how you're deploying your Kubernetes application. So let's take a look at how that looks in real life. I'm going to go back to my trusty Sumo Logic deployment, and here I'm going to now open up my Explore tab. And by Explore, we have multiple different views, but in this case, I'm going to focus on my Kubernetes deployment view because that's how we're going to be able to get to those optimizations. I'm going to go into my demo environment, into mobile banking, and then I'm going to go into this account service that gave us such a headache because of that database. And we see that we have errors here, etc. But we've already solved for some of this. So let's go look at how I can optimize my Kubernetes deployment. So here we can go and look at how we can go and really optimize this deployment. And I'm going to just wait until it it loads. So here we have our container current aggregate and Slack and risk. So we have a risk percentage. We have our cost optimization, reliability optimized. Obviously, this is a smaller deployment, but for your deployments, it's going to really grab all of the information that your application is generating to give you these additional views, as well as what your CPU looks like if you're going to be cost optimized and balanced versus reliability optimized. That's how your CPU works. And remember that I mentioned that setting all of these parameters manually can be a very tedious and hard process. We can go into this detailed view of our Kubernetes deployment that will then allow us to go in and look at the recommendations on this table that then we can grab and use to then go and configure our deployment. As I mentioned, this is done by profiling all of these containers against your specific behavior of the application and what errors you've seen, how your application has been behaving, and then applying that those analytics around it. So with that, I wanted to close out just by summarizing that Sumo Logic Observability allows you to use the data, correlate across all of your different deployments, all of your different telemetry from your cloud deployment to your serverless to Kubernetes, and bring it all together by using a single thread, by connecting the traces to the infrastructure that's running behind it, and giving you the power to quickly troubleshoot, but also to optimize. There are multiple different use cases that Sumo Logic provides, such as looking at how your cloud deployment looks like, and bringing, again, all of the information into a single platform that you can then use and leverage to troubleshoot as well as optimize. And with that, I'm going to open it up for questions. Please feel free to use the Q&A section of your webinar. And let me open it up here. So I see one question coming in, and it's how does Sumo Logic connect all of the telemetry? So when you saw the first diagram, I'm going to just go in here, and you see how everything is coming in. When the data is ingested into the Sumo Logic platform, it's then tagged with information specific to the source of where it's coming from. So with AWS, we have connections around, like, we know what account, what region, as well as what telemetry, what EC2 instance. So that is all brought in and then tagged so that when you're trying to navigate, you don't have to write queries. It's all connected, so you can click through this entity model and be able to go and switch the dimensions from for what you're trying to get to. So that's the metadata enrichment is a lot of what Sumo Logic does to be able to give you this complete view, so you can then do all that troubleshooting. So I have another question. How does it work for pods that are at scale and multi-cloud deployments? So again, if it's multi-cloud, we know where those are coming from. They're tagged with metadata, and our platform is amazingly scalable. So it doesn't matter if it's hundreds or thousands of pods, all of this information can be ingested in real time and then analyzed. I hope that answers your question, because we do support services like EKS, GKS, and all of that information is then tagged with the relevant metadata. So you can then look at your multi-cloud deployment. There's actually a case study on the website around LendingTree and how they implemented Kubernetes on a multi-cloud, and having this connection really allowed them to be able to manage it across multiple clouds at that large of a scale. Can slow queries if we have APM running on the database? When we connecting to the database, I don't know about the APM connecting to the database. However, we are able to look at specific database information. So for example, here in the DynamoDB, we can go and dive into that specific service. And then look at the different events over time, throttle requests, and then we can filter those out by latency, depending on each specific, for example, table name, etc. So I don't know if that answers your question on working with specific databases, and we have hundreds of integrations. So it's not just the DynamoDB, SQL, MySQL, all of that is supported just by going to the app catalog and adding that app. And the beauty is that all of these apps come with their out-of-the-box dashboard. So you don't have to spend time like not just ingest the data and then you have to spend hours creating your dashboards. We give you the starting point where you can start just using it and then improve upon it as you need it. Any additional questions? Trying to look to the Q&A panel. Well, if there are no more questions, I really appreciate your time. I just want to show one last thing, which is a newer view of this, which is for application observability, looking at application service views. So you're able to have a bird's eye view of how your application is performing, and then be able to report on it. And thank you a lot for all the questions. So with that, I hope that this piqued your interest and you want to dive a little bit further. If you need more information, it's my contact is going to be posted. Yes, so this is a wholly separate offer from the managed scene, but it's the same platform. It's all so Sumo Logic is an observability and security platform. So yes, this is a completely different use case around application observability, but the information, the telemetry could be shared with security use cases. So you don't have to have two different tools looking at two different data sets. Great. Well, thanks again for your time. I see that my contact information has been posted, and please come join the conversation at slack.sumologic.com. We can talk live if you have additional questions. And with that, I wish to thank you for your time.